Okay, so this is the review worksheet for Unit 4 Part 2 video. So I'm going to jump forward and start with question number 23. So I'm going to start with question number 23. All right, so I want to combine these two fractions. So I'm trying to combine these two fractions. So before I do that, I can see that first this factor, so I want to make sure I do that before I try to find a common denominator. And then because I have a negative here, I want to distribute, or I'm subtracting, I want to distribute that subtracting. So I'm going to go ahead and do that first. So this is going to turn into a positive and then negative and a positive, right? Anytime I have a subtraction, I always want to make sure I distribute that. So then for this fraction, I can't factor anything, so I'll have 2 over x minus 3. And then plus, and then negative 3x plus 4. And then for the denominator, this is a difference of 2 squares, so I have 2 perfect squares subtracting, so I'm going to factor both of those, or factor that. And so then from here, I want to look at my denominators, because I want to try to get a common denominator here, so I'm going to highlight those. So for my common denominator is actually going to be, let's see if I can fit that right here. So I have an x minus 3 on the first fraction, and then here I have an x plus 3. And then I have an x minus 3, but I already wrote it, so I don't need to write it again. Okay? So again, I'm trying to add these two fractions. I'm not trying to solve. So because I'm trying to combine and add two fractions and not solve, I want to keep my fractions balanced, not my equation balanced. So what I need to do is I need to get my fractions to have the same denominator, not get rid of them, right? Get the common denominator. So I need to multiply this fraction by x plus 3 to the top and the bottom because I'm trying to keep my fraction balanced, not my equation balanced. So now my fraction is balanced, so I multiplied top and bottom by x plus 3. I have matching denominators, so I want to distribute and combine, not factor and reduce, right? I need to get one fraction before I can reduce. So I need to distribute. So I would have 2x plus 6 over my common denominator. And I want to combine my fractions before I try to reduce. So here I know I can combine 2x and negative 3x, positive 6 and positive 4. So 2x minus 3x is a negative 1x, and then 6 and 4 is 10. And it looks like the best I can hope for is to factor in negative 1 out of the numerator. Okay? And now for question number 24. So this is one of those fill in the blank ones that some of us have a hard time with. So let's see if I can see one more here. Okay, so for my common denominator, so that's what's going to go down here. So if I look at my denominators, I have x minus 4x and x to the third. So I know x minus 4 is part of my denominator. And then here I know x goes into x to the third, so I only have to have an x to the third here, right? I don't need to also have the x. So for 7, I already have an x minus 4, and I don't have an x cubed. So I have to multiply the 7 by x to the third, right? So I would multiply by x to the third to the top and to the bottom. Let me do it on this side. And that's to keep my fraction balanced and to get the common denominator. So for the x, I need to try to get here. So I know I need at least the x minus 4 to the top and bottom. And then to make x into x to the third, I need an x squared as well. So I have to multiply the 2 by x squared and x minus 4 so that this denominator will be that denominator. And then finally for the 3, I need to multiply by x minus 4 because x cubed has to have an x minus 4, so that would go to top and bottom. Okay. All right, so now this is where we start to screw up, right? Because that was all this simplifying with adding, subtracting, multiplying, dividing, getting common denominators, things like that. And so this is where we try to clear fractions from here on out. And so we do these problems differently, right? So we need to be keeping that in mind. Okay, so for question number 25, I want to get my common denominators, so I'm going to highlight my denominators. So that's pretty easy. My common denominator is x, so my lowest common denominator is x. So then I want to multiply everything by x, right? I want to multiply the top by x and the bottom by x, right? And I can do that because that keeps my fraction balanced. And then when I do that, I want to go ahead and distribute. So I'm going to multiply the x to everything. So when I multiply here, x times x is x squared. And then when I multiply the x to here, so I have 1 over x times x, these x's will cancel, leaving just a minus 1. And then distribute here. So 1 times x is x, and then distribute. And so when I multiply these two together, these x's will cancel, leaving just a plus 1. And then I want to try to factor and reduce. So I know I can factor the numerator. I have a difference of 2 squares. And then here I can always take out at least a 1. And then I look for matching factors, so that would be x plus 1. And then I'm left with x minus 1 over 1, or just x minus 1. Okay? All right, and then let's jump to number 30. So for number 30, we're looking to solve for x. I want to find my common denominator. And those don't factor, so my lowest common denominator, I have an x minus 2, and I have a 4. So this is where I keep my equation balanced and not my fractions, right? So this is different, okay? This is different. So I have 2 over x minus 2, and then I want to multiply the left side of the equation by 4 and x minus 2 because that's my common denominator. And then I have x over 4, and I want to multiply this side of the equation by 4 and x minus 2, right? So this time I'm keeping my equation balanced. So I multiply the left by the same thing as by the right. So LCD on the left, LCD on the right. And that's okay to do because I'm keeping an equation balanced. And then with this pair right here, I look to see is there anything that reduces. And I should always be reducing my denominators because that's what I'm trying to do. So I'm left with 2 times 4, which is 8. And then when I look at this pair here, the 4's cancel. And then I want to distribute the x. So I would have x times x, which is x squared. And then x times negative 2, which is negative 2x. And then I have a quadratic, right? Anytime I have a squared term, I always want it to equal 0 before I try to solve it. So this has to equal 0. So I'm going to subtract 8 from both sides. So that would give me a 0. And then this I can't combine anything, so I'm just going to put it in order. So x squared, negative 2x, negative 8. Okay, and then that's just kind of weird looking, so I'm going to flip that around so it looks normal to me. And then I want to try to list my factors, and hopefully it factors so I don't have to do quadratic formula, right? So let's see here. So there's my factors. So when I'm looking at that, I know one of these numbers has to be negative, so that when I multiply, I get a -8. And then when I combine it, I need to get a 2. So it looks like 2 and 4 will be the ticket on that, because 2 minus 4 will give me a -2. And so I want 4 to be negative. And then once I get here, I want to solve each equation. So I'm going to split that. So I would have x plus 2 equal to 0 and x minus 4 equal to 0. So I would subtract 2, so x equals -2, and then add 4, so x equals 4. Okay. All right, so then for my solution, so I'm going to write that over here because I'm getting kind of tight on my solution. So I have x equals -2 and 4, and then I want to go ahead and list my excluded values, which come from my LCD, right? So if I look at my LCD up here for my excluded values, so I know x can't be equal to +2, and this doesn't have a variable, so I won't get a value out of this. So I know that I have x can equal -2 or 4, and I know specifically x can't equal 2, which doesn't really change anything because I know that that's not one of the solutions here, so I have no extraneous solutions. And then it asks whether or how many solutions I have, so I have 2 real solutions, right? So 2 real solutions, and then that's that, okay? All right, and then let's take a look at, so 32 I had already worked out, and I'm not sure if I had done that in class or what that was about. So there's 32, so I'll leave that up there for a second for you to take a look at, and you can press pause and try to figure out what the heck I did there, okay? And then let's take a look at 34. Okay, so for question 34, so I know that I can factor the denominator there, so I'm going to go ahead and do that. I'm going to do that on a separate piece of paper. So I have 1 over x minus 1, and then plus 1 over x plus 2. And then that's a trinomial. So I didn't actually list my factors there, but you guys can do that part, hopefully, by now. So I'm getting tired, so I'm getting a little lazy. Okay, so now for my common denominator, I know that I have x minus 1, x plus 2, and then I have both of those over here as well. So then my common denominator will just be x plus 2 and x minus 1. So I'm getting my equation balanced. So if I want my equation to be balanced, whatever I multiply to the left, I also have to multiply to the right. So on the left side, I'm going to multiply by x plus 2 and x minus 1. And to the right as well. Okay? All right, so left side and right side. So multiply to the left, multiply to the right. And I multiply by my both parts of my LCD to reduce and cancel my fractions. So the x minus 1 cancels. And then when I distribute the 1 in, it's not going to change anything, so I'm left with just x plus 2. Here the x plus 2's cancel. And when I distribute in the positive 1, I'll just still have x minus 1. And then over here, the x plus 2 cancels as well as does the x minus 1, leaving only equals 3. So to try to solve this, I need to combine like terms. So I'm going to do that first. So I have a 1x and a 1x, and a 2 and a -1. So I'm adding 1x with 1x, which is a 2x, not an x squared, right? Because that means I'm multiplying 2 x's, which I'm not. And then 2 and -1 is positive 1. So I don't have a squared term, so then I'm just trying to isolate the variables. So I want to get x by itself. So I'm going to subtract 1. and then divide by 2. So then I get x equals 1. And then I want to look for my excluded values. Lost my train of thought there. So for my excluded values, so let me write my LCD over here just so I can look at that. My LCD was x plus 2 and x minus 1. So from my LCD, I know x cannot equal negative 2 or positive 1, right? So negative 2 or positive 1. So because x cannot equal negative 2 or 1, and my only solution was 1, that's bad, right? That means this is an extraneous solution, so x can't equal 1, which was my only value. So then that means, actually, then there's going to be no real solution for this, right? I would have no value because I said it could be 1, but x cannot be 1, so then I have no solution, okay? All right, last one I'm going to do. So question number 38. Let's take a look at 38. So for this one here, it says to solve the equation f of x equals g of x algebraically. So I'm going to take that equation and equal it to that equation. So my LCD is x minus 2 and x minus 3. So I'm going to try to keep my equation balanced, right? I want to keep my equation balanced, not my fraction. So I need to multiply the left side of the equation by the same thing as I do to the right side. So I'm going to multiply the left side by my LCD, which is x minus 2 and x minus 3. And then whatever I multiply to the left, I also multiply to the right. So then when I look at this pair over here, the x minus 2's cancel, and I'm left with x minus 3 times 6, so I'm going to distribute. So 6 times x and 6 times negative 3. And then over here I look at this group, and I know x minus 3 cancels, so I'm going to distribute the 5. So I would have 5x and 5 times negative 2, which is negative 10. And then I do not have a squared term, so I'm not trying to equal it to 0, I'm trying to isolate the variable. So there's no squared, so I want to isolate the variable. So that means I'm going to subtract 5x from both sides of the equation. So 6 minus 5 is 1x, and I still have a negative 18. And then that's 0, and I still have a negative 10. So again, I'm trying to isolate the variable, right, not equal it to 0. So then I'm going to add 18 to both sides. So I would have 1x equals 8, yes, and then divide by 1, which won't change it, so x equals 8. And then for my excluded values, look at my LCD, so x cannot equal 2 or 3. And so neither of those are my solutions, so that would be my answer. And that's it for the homework help videos for the review.